Good morning, welcome back. What I want to look at today is again mathematics and rotations and reflections using matrices. Now, a lot of this you should have done already and make yourself familiar, but this is for you to be able to make sure that you can practice your mathematical skills, because when you're in the examination room, it is a different ball game there. Okay, so now this will be for you to make sure you can understand it. If you have any doubts or questions, go and look at the electrical principles work. Look at mathematics GCSE level. Look at the engineering mathematics also as well, which shows you how this should be done and give you brilliant examples that you need to work out. Now, always write out the examples, okay? I'm afraid that's what I had to do when I was at college. Always write out the examples, okay? And then it stood me in good stead, okay? So what I'm saying now, rotations and reflections using matrices, okay? And it's GCSE maths. Now, we'll take the section. Earlier in your course in units 26 and 34, you looked at a variety of ways in which a shape could be moved around on squared paper. Now, you would have done this in school. You would have done something like this in year 9, year 10, year 11 as well, basically. So use that skill and knowledge from that then. You haven't actually used 26 and 34 in this case here. I don't need to go back that far, okay? But in each of these, the size of the original shape remains fixed. We also looked at the process of enlargement. Now you're all familiar with enlargement, making a shape look larger or smaller in some cases, in which the size of the shape did change, becoming either larger or, rather strangely, smaller. These processes are all types of transformation. The original shape is often called the object. Let me just get, so we can, I highlight some of these points for you, okay? Here we have the original shape is called the object, okay? And all I'm going to do is just to highlight that for you, basically, okay? Well, circle it, okay? The final shape after transformation can be called the image, okay? And here we have ourselves as the image, okay? Work through the following example for revision, okay? A triangle tile is shown below, resting on a sheet of graph paper. Find the image of A, B, C on each of the following transformations, angles of course. Translation 1 to the minus 2, rotation of 90 degrees about the origin, 3 reflection in the y-axis, 4 enlargement center the origin scale of factor 2. Okay, let's look at the solution to this now. Translation, matrix 1 to the minus 2 means move the triangle 1 unit along parallel to the x-axis, and 2 and -2, sorry, parallel to the y-axis. So here we have -2, and here we have our shape. Now try doing this for yourselves, okay? It's important that you try and do this for yourselves. But you can see here -2, 1, 2, -2, that shape. This is now, that's the object. This is our shape that we are bringing in on our graph. Now let me try and remember to use your this is our image. Okay, thank you. Sorry, I forgot what it was then for a moment, but okay. Now try and plot these. Again, let's look at that. Translation means move the triangle 1 unit along parallel to the x-axis from the original, okay? That's the position of the original, and you move it along from the original, which will bring it in this point angle at this point here, okay? Okay, basically. And -2, 1, -2, that lines up with here, okay? As you can see, basically that let me just put some dots, okay? That lines up with here, basically. You know, my dots are not quite straight, but you get the idea, yes? Okay. Okay. The tile appears to slide over the paper, okay, by that simple action. Note the sides of the image are parallel to the corresponding sides for the object and in the same direction. Now here, rotation of 90 about the origin. Positive rotations are anti-clockwise. Negative rotations are clockwise. Okay. So let's look at what we've got. So you can see from our original point, we have now moved it to here. We imagine putting a pin through the origin and rotating the diagram through a right angle. So you would put a pin here and you would simply turn it around, okay? That's what they've done in this case, okay? Now make sure you get the practice in for yourselves, because you can only understand this by your own perception and by doing the work yourself. Draw out the diagram, get the work done, okay? And this is what we're looking at here now, okay? That's the origin. Okay. Notice that the sides of the image are pointing in a different direction from those of the object. The angle of rotation can be measured by looking at how any point has moved. A0A equals B0B equals C0C equals 90 degrees. Reflection in the y-axis. This time we imagine folding the paper along the y-axis. The tile will flip over. Okay, and now this is where we are. That still remains the original, and this is our new now position. Okay. Now this time we see that we obtain a mirror image of the tile. The original shape has turned over. The circular pattern on the object is reversed in the image, just as left and right are reversed when we look in a mirror. We could say there has been a change in handiness, if you like. Enlargement center, 0 scale factor 2. In this case, we join each point to the center and stretch by a factor of 2. And here you can see what has happened here. Okay. The shape has become larger by that adjustment. The most obvious feature is the change of size. Each side in the image is twice the length of the original. And that is what we're looking at, okay? Sorry about my squiggly, just went offline. Okay. You may also find problems where you are given the starting and final positions and you must describe which transformation has taken place. When studying the object and image, it may help you to use the following flowchart. Start. Is there a change in size? If yes, it must be an enlargement. State center and scale factor. If no, then you come to the next stage. Is there a change in handiness? If yes, must be a reflection. Describe axis of reflection or mirror line. Okay? If no, you're here. Is there a change in direction of sides? If yes, must be a rotation. State center of rotation and angle. If no, must be a translation. State distance moves parallel to x and y axis as a column vector. Okay. Now you should all not be familiar with vectors because you would have produced them somewhere along the line previously. Now working for example 2, cover the right hand side of the page and decide for yourself before looking at the solution. Example 2. In each diagram, the shaded triangle ABC has been transformed into image ABC. Describe fully the transformation used in each case. Okay. Now, tell me what you're thinking and tell me what you are looking at in regards to this. Okay. Now I'm not going to say anything here to you. I want you now to look at this for yourself and then decide what's happening. Okay, again, proceed. Now, okay, and you're now looking at this exercise 1, so let's look at what's happening here. For the diagram below, describe completely the transformation which will take rectangle ABCD to ABCD. Now these are for you to do. Now some of you should have had know this by now and be familiar with it and should be able to work through it. Okay. Now find the image of the shaded triangle in the diagram below. After enlargement, scale factor 2, center P 2 to 1. 2 after rotation of minus 90 degrees about P. Solution. Solution, okay? And again, that's for you to work through. I'm not going to, and a similar thing here as well, okay? Again, work for you to work through. Now here, you're taking the pieces and you're turning the shape around, okay? So drop down to here, that becomes C. Here, that becomes B, and that becomes A, okay? You can do the similar thing here. You're doing like a transposition. You're bringing this down. This is now being turned clockwise, okay? The matrices and transformation. Now we remind ourselves about transformation. We will look at the way in which matrices provide a neat way of describing them. You have already done this for translations. Okay. Now again, look at what it says. Look at how the examples are worked out. Okay. Now you need to write this information out for yourselves. Don't try to do it off the board. It's not always going to work as you think. Okay. Look at what's been done here as well. Okay. 6, 9, 6 to the 9. It's 6 to the 9 basically. Okay, so make sure you extract the information, write it out, make it your own. Okay, nothing for me to say here other than to provide you with more information and exercises, okay? It's a number of pages to do, so I am hoping to do this in a given time, normally about half an hour or so. Look at the solution, usually solutions to help you arrive at the answers, okay? Okay, and look at this, you look at the solution here, okay? In respect of what you've been asked here, okay? Okay. And again, keep that in mind, make sure that you understand the concepts, know how to write them out. Second and first transformations, okay? As you want, she'll still be up there. Things that you don't need a woman that can actually, but there's always going to be something, isn't there? Always be something, one thing or the other. The main thing is to make the most of what I can do for myself. It's okay, I was just considering an issue I have in mind. So sorry about that. Sometimes I forget I'm on a video. Yeah, it's okay. I was just thinking how the cooking and the washing and so forth that man has to do these days can sometimes be a little bit tedious. Okay. Okay, right, continue with this. Alright. Thank you. And here are some exercises for you to do. Okay. And I hope I've covered this in a reasonable time. I think I have actually, but we'll see how it goes. Okay. Okay. Thank you. Let me pan back a bit Make sure I can get it all in. Okay, and let me just go up. All I'm doing now is just making sure to recap that I've got it all in frame, because sometimes when I go back it just sometimes be out of frame and I have to redo it again. Okay, which can be a bit of a pain in the pendodendrons. Okay. Yeah, okay, so I have to go roll back through it completely. Okay, making sure that it is in view. Okay, thank you. I hope you found this useful. Okay, and please have a good day. Bye bye.